So what number was this, just so we know?
8.
On page?
47.
All right. I forgot to record, so if people watching the video later, they can at least see the math behind distance and displacement. George, what do you got?
Can we do number 50, section 1-3? I don't know the page. I think it's 23 meters. Actually,
I don't have the text for me, so you need
Page 38, so the givens are 23 meters per second.
But I need the problem. I don't want to just write down the answers, guys. We need the problems. Gianna, go ahead.
Peacock mantis shrimp feed largely on snails. They shatter the shells of their prey by delivering a sharp blow with their front legs, which have been observed to reach a peak speed of 23 meters per second. What is the speed in kilometers per hour?
Oh, so conversion. Okay.
I just wanted to see.
Yeah, that's fine. I'm not going to answer this exact one simply because is this right out of the problem set? I'll just make a conversion one for you. Okay. So let's say we've got 15 meters per second. We want to convert that into kilometers per hour. So converting from meters per second to kilometers per hour. How do I get rid of meters? How do I get rid of meters? What do I do to do that one? All right. So I recognize this. So I put right away meters in the denominator. What? Kilometer up top. What do I know as a conversion factor here? What do I know as a conversion factor?
1,000. So kilos, that's 1,000. So 1 meter. 1,000 km.
So you want to put 1,000 on the top or on the bottom? Bottom. Let me go over this because a few of you are doing exactly what Ernest did there. That's all right. He said 1,000 up top. 1,000 goes in the bottom here. Kilo means 1,000. It already is there, so you don't have to put it. So to compensate for the word kilo, which means 1,000, you put the number 1,000 in the bottom. Okay? That's all right. Just think about prefixes though. Kilo means 1,000, so it's already there. So I'm good with length. What else do I have to do? Gabe?
Well, you have to convert seconds to hours.
So where do I put seconds to get rid of it?
Seconds on top.
Why?
Well, because seconds is on the bottom.
Very good. And what goes in the bottom now?
1 minute.
And 1 minute is how many seconds?
60 seconds.
Okay.
And then next 60 minutes over 1 hour.
Okay, get rid of minutes. Put minutes up top. And hours down below. That's it. And we're there. Kilometers per hour. Can we do the math? Yeah. This is just an arbitrary problem. Random.
Oh, well.
It was from a problem in the text. But
From like the actual question.
yeah, from the actual question, I'm sure you have a number, but I'm saying you can do the math on your own for this if you have to do it, right? You obviously would not leave it that way. Again, I told you I'm not doing calculations for you guys. You have to have your own calculator. You have to have your calculator in class. So if you want to check it, you can. But again, you should be able to do this on your own. I will say this again. I've said it a few times before. You have to practice calculations because when it comes to the test, I can't tell you how many students come to me and say, I don't know how to plug this in. How do I type this? I'm not showing you how to use your calculator on the test. That's why you use it in class. And then you ask me if you need help on it. I'm happy to show you how to use your calculator, but not on the test itself. Understood? So I'm trying to figure out the average velocity between time equals 0 and time equals 5. Time is measured by 1 second. Displacement was measured by 1 meter each increment. This is the graph from the figure. What do you do for a problem like this? How do you find the average velocity? The average velocity. It's a simple definition. Average velocity. Yeah, but you need more specific. When you're finding average velocity, I think I put this on your formula sheet like this, right? Displacement over time. But in this case, how do you find the displacement is my question, I guess, right? It's the right formula, Mateo, you're right. V bar equals x over t. But what's x in this problem? Which x are you going to use, right? Because it said find the velocity between time equals 0 to time equals 5. That's what we're doing here.
Isn't this displacement on?
How do you get the displacement?
Because that one right there, so that's 3, and then you end at 2 meters.
So is the displacement 1?
What is negative?
It's negative. It's negative. So we're talking about -1 here, okay? So the displacement here is -1 in this case.
Wait.
That's what we have to consider, because it goes down.
That's right, so if it were 3 to 4, that'd be positive.
Oh, weird.
Okay, so let me go over this again. The problem said find the average velocity between time equals 0 and time equals 5. Not 3 and 4, not 1 and 2, not 2 and 3. So it turns out I don't care what happens between 0 and 5. All I care is how much did it change its position by? Where did it start? Everybody, where did it start? No. 3. 0 is time, yes. Sorry. What location did it start at? 3 meters. What location did it finish at? So it loses by 1 meter, or it decreases by 1 meter in location. So it turns out that this is just -1 meter here. And then what's the time taken? 5 seconds. So the average velocity is -0.2 meters per second. Okay, that's a bit of a tricky one. Some people, here's what I've seen done in the past. Ready? They find the slope of this line to get the velocity here, which is right. The slope of that line is the velocity between 0 and 2. Then they find the slope of this line to get that velocity, and then they find the slope of this line, and they add them up and divide by 3. And say, if I get 3 velocities and I average them, isn't that just the average velocity? Why would that not be true? It's difficult to answer this question, but I think some of you could see it, and we'll go over why. Why can I not just find the velocity of each segment? Remember, the slope of the line is velocity. Why can't I find just the 3 slopes separately and average them? That's what average means, doesn't it? Why can't I? I'm telling you can't, but why not? Okay?
Because of the time.
The time. What's different about each segment? The first segment, how much time elapses?
2 seconds.
The middle one, though, how much time?
1 second.
Only 1 second. So that middle segment is like not as much of a value. It doesn't weigh as much in on the average. It's like a weighted average is the term. This is like a weighted average. Imagine, it would be a sweet world, wouldn't it, if you could say, I've had 40 homeworks and got 100 on all my homeworks. And on my 3 tests, I got a 50. So I'm just going to average 40 homeworks at 100 a homework and 3 tests at a 50. That's not bad. I got 4,300 points from homework and 3 tests. That doesn't work that way though, right? How does it work? Tests are worth how much? 60%. Homework's worth how much? 15%. So it's not weighted equally, your grade. That's what this is. If this was 2 seconds, and this was 2 seconds, and this was 2 seconds, then yeah, you actually could just average all 3 of the averages at velocities and you get the average velocity. It works out that way. But you can't do it here. Okay, you can't do it here, it's a weighted average. Now, what are you guys really doing? Here's what you're doing. Draw this if you need to. Draw a dashed line from start to finish. You're really finding the slope of that line. That's all you're doing. Do the math, please. Follow me. I'm going to point. Follow me. To find the slope of this line, isn't it rise over run? Rise is -1. Run is +5. -1 over +5. This is just the slope of that line. Again, this x is a change in 1. This t is a change in 5. -1 because I go down. +5 because I go to the right. So the slope is -1/5. -1/5. Okay, again, -1/5 is the slope of the dashed line. It is the average velocity. All right? This is definitely an extension of what we did from where? From the lab, from your definition of displacement, of velocity, of time. So again, velocity is defined as the change in position over time, or displacement over time. You've only displaced -1 meter over 5 seconds. Okay? Definitely a fair game kind of question for your test. I'm glad that you asked that question. You asked the question, right? Yeah, follow up?
Also, so can you just avoid all that math and just find the slope?
Absolutely, 100%. Yep. And technically, you'll learn about this in pre-calculus. That dashed line is called the secant line. Secant. Remember in geometry, you had the secant to cut through the circle in 2 locations? In math, In calculus, you talk about a secant. And if you have a curved function and you want to find the rate of change between two locations, you connect those locations with what's called the secant. That's what we're doing here, really. Okay? So the slope of the secant is equivalent to the average velocity. If you want to memorize that, that's fine. And that's something that is good to memorize, because by memorizing it, you're really understanding what's happening here.
So on the problem sets, not all of them were like, where we have to write.
Yeah, you should just write a statement for those.
So are there any questions on the test?
Absolutely. Let's go over the format of the test. I was waiting for somebody to ask that. So format of the test is very important. It is the same all year. I'm telling you now, it's the same all year. Tests will range between, I'd say, 40 to 50 points worth, if that makes sense, okay? This first test is a little bit shorter. It's earlier in the year. It's going to be a 40-point test. It's also a B day tomorrow. So I always make sure on B days to make them either 40 or 45 points. It's a little bit shorter because you have 5 minutes less during the period. Before I go over format, quick reminder. If you get extended time on any assessments, formal assessments, make sure to email me. The easiest way to set up time is during a free period that we both have in common. The second easiest way is before school with either Mr. Hall or Mr. Joseph. They'll be here. I'm never here before school, but they'll get you started. I don't mind doing that, but on the day of the test, not the day after. So if the test is tomorrow and you want to take extended time, not during the day, you need to come tomorrow morning. Okay? If you want to take it during the day, just find a free period that we both have in common. Or come during the other class while they're taking the test. See when the other class has this period tomorrow and see if see if there's room in the classroom. I can tell you right now, if you're free tomorrow is a day 3, right? No, today's day 3. No, tomorrow is. Tomorrow. You guys are back to back tomorrow. So, let's see, you guys are the second period tomorrow. So, first period, the other class is taking it. So, if you want to take extended time tomorrow during first period, you can do that during the second half of first period if you want to, and just continue into second period. Anyhow, format. Part 1 is always multiple choice, worth 2 points each. This will mainly be conceptual stuff. If there's math involved, it is extremely basic math. Okay, it is not difficult math if it's here. So a problem that you have to add things together could be involved here. A person moves from A to B, then moves from B to D, then from D back to E, and I have a figure. Find the total distance traveled. Simple math, adding 4 segments together. Or maybe the question says, is the distance equivalent to the displacement in this figure? And your answers are yes, no, not enough information, or something like that. But that would be simple math, but mainly conceptual. 2 points each. The test is mainly a third, by the way. So there's 12 points worth, I can tell you, on this test. 12 out of 40 is almost a third. 13 out of third is a third. So it's about a 33%. Let's see, part 2 is conceptual with short answer. Short answer, conceptual. So this is like what Matei asked about. If a question says, looking at the graph to the right, describe what happens to the object's position. What does this tell you about the velocity? Remember the summer packet? Remember those 2 graphing questions on the summer packet? Remember all the graphing ones we've done? That's fair game for conceptual in the middle, short answer. Because again, it wouldn't really be multiple choice, but maybe I'll have multiple choice with the graph also. But these would be open-ended. Open-ended simply means no answer choices. These are worth 4 points each. Either they have 2 parts or 1 part. Sometimes if the questions are shorter but they're related, I'll have parts A and B. Each part is worth 2 points then. But these are worth 4 points each, and there are 3 of them. So I'm telling you how many of them there are for each. Yeah?
So the problem sets doesn't cover everything that's going to be on the test.
I mean, when you're studying, good ways to study, and anything is on the test from anything we've done. So for example, did we do stuff with the water bottle and direct and indirect relationships on the problem set? No. But we did it on the second day with direct variation and indirect variation. Remember that with density? That kind of stuff is fair game for the test. So anything can be. But the problem sets are good sample questions. That's what they are. But you should study your notes. You should study your problem set. You should study tonight. You should do the homework because the homework for 2-1 to 2-3 is due tomorrow. So it's good practice for tomorrow anyway. I'm not going to include questions from the first lab because I didn't give it back to you yet. Okay, just so you know. So you don't have to worry about like drawing a line of best fit. But anything else that we covered, scientific notation, dimensional analysis, the stuff that was a little bit different, okay? Yeah.
Would there be points on the, like, there would be more than, let's say, 3 short answer questions, like, you could pick, it's like, would we ever get to pick 3?
Only time I give you a choice and let you omit one is on the math, and I only do that sometimes, okay? You'll never have omissions for the first 2. Sometimes, I didn't do it for this test. Sometimes on the last 2 questions, I say, choose one of the next 2 questions to answer. And that's simply because I had a full test, and maybe it was a B day, and I didn't want to have 2 questions, and they're very close to each other, so I say pick one of 2 to answer. But on this test, I'll tell you now, the whole test is completed. Okay? The last part, the math, they're worth different amounts of points. So I can't tell you how much they're worth, because it depends on the problem. But I can remember if I'm right that there are 5 of these. Okay, so if you think about it, multiple choice, pace yourself. I'm never going to spend this much time on the format of the test at the end of the rest of the year, but I want to spend time because it is important. Multiple choice, how long should a multiple choice you think take? What do you think? What's a reasonable amount of time? You have to read, mind you, so it does take time to read. Yeah, I'd say minimum a minute. No, minimum 30 seconds, maximum 1 minute, 30 seconds, depending on the problem. Some you'll be able to answer like that. Some you have to think about it and read through several times. I don't always put 4 choices. Sometimes I put 5. Sometimes I put 3. Sometimes I put 2. So the number of choices varies. I don't make up choices just to make up choices. Sometimes I'll put a random choice that you know is wrong just to make you laugh. But I didn't do anything crazy for this one. So 6 of those at 1 to 2 minutes each. That's how many minutes of your test? That's between, if you do it in 30 seconds, that'll take you 3 minutes. If you do it in a minute and a half, that'll take you 9 minutes. So this is, let's say 6 minutes it would take on average to complete this section. Short answer, I'd say 1 to 2 minutes per problem at least. Maybe a little bit longer because you have to think about how you're going to word your answer. I do not want answers that are not grammatically sound. So write things that make sense. Obviously, if you spell something wrong, it's not the end of the world. But if I don't know what you're saying, I'm not sitting there deciphering it for 10 minutes. So make sure you think through your answer. So what should you use on the test? Probably. Please use a pencil. I require it on the math section. I always say use a pencil. Use a pencil. I even put it in the directions. But even on the short answer, so many people last year wrote out the stuff and then that doesn't sound right, crossing it off. And I'm having trouble reading. There's arrows everywhere. Please make sense of what you're writing. Okay, make sure it actually is reasonable. So let's say that this might take 10 minutes. If it took you 3 minutes per problem, it's 10 minutes. So that's a max time I could see. That leaves you 24 minutes because it's a 40-minute period tomorrow. So that leaves you about 5 minutes per question. These are total times, and that's per question, okay? So 6 minutes total, 10 minutes total for that whole section, leaving you 5 minutes per problem approximately for the math. How long did it take you for your homework, for your problem sets? Is 5 minutes per problem reasonable? I think it might be reasonable for some. I think for others you might have had trouble. But again, practice, practice, practice. Givens, desired, formula, solution. That's the format every time for the math. If you follow that format on this test, it will be easier for you. You will definitely have a conversion on the math. You can jot these down. I'm telling you topics. Absolutely have a conversion on the math. You will absolutely use velocity, displacement, and time on probably 2 questions on there at least. What else? Absolutely. You will definitely, overall, for the test, need to be able to interpret graphs. But they will be position time graphs, not velocity time. Position versus time, what we did earlier, the example we used earlier is a great example. Yeah, other stuff. You don't have to, but if you don't write stuff down and your answer is wrong, you get 0 points worth out of like 5. So if you put an answer with no work at all, and you just put your answer for distance is 12 meters, right? And say the answer is 11.5, sorry, but it's no credit at all. But if you show all your work and I see that it was a simple mistake, then you probably get 3 out of 4 points on that problem. So you take the risk of whatever you'd like to do. If you don't want to follow that format, but you're still going to show work, that's an in-between probably way to go. Okay? Yeah.
Once we go over.
Yeah, we're done with format. That's pretty much the format.
Could we go over like interpreting graphs and other examples?
Sure. So stuff from graphs. Let's talk about graphs. We draw an arbitrary graph and talk about it, and you guys could write stuff. I'm just going to talk. So when I talk about different parts of the graph, I recommend you write it, or at least later, maybe go back and watch this video again. Slow down. So all I'm going to do now is just draw a graph of position time. We're not going to look at velocity time because it's not in this section. That's in the next section. That'll be in the next test. So let's say the graph looks like the following. So we've got position time. We could see the motion of this object. I'm going to talk for a little while, all right? I could say here, the object starts at the origin. Or in terms of our lab, the object starts at the motion detector. Remember we had the lab yesterday with the motion detector? So the object starts at the motion detector. The object then travels away from the motion detector at a steady rate with a velocity equal to the slope of this line. Slope of the line is the velocity. Slope of the line is the velocity. The velocity must be positive because the slope is positive. Then the object does what? It stays at the same position the whole time. I don't even care what the number is here. You guys see that? I don't care what the number is. But I know that it stays at the same location. So let's say this were 2 meters. It's at 2 meters. It's still at 2 meters. It's still at 2 meters. It's still at 2 meters. Then it stays at the same location the whole time. Then what happens? Yeah, it dramatically increases speed. It runs away. It starts running away from the detector very fast in only a small amount of time. Look how far it runs away. Almost impossibly far away, if you think about it. That's almost the slope of infinity or undefined. So it runs away. Remember here, what was the velocity here? What was the velocity here, everybody? 0. Because the slope is 0. Now the slope almost becomes vertical here. So that means that the person, again, I'll show you. 2 meters for the beginning maybe. Stops. Waits. Then, boom, starts running fast. And then slowing down. Until here, the slope at the top here is back to 0. How do I know the slope? Think about the slope when you have a curve as a tangent line. Do you remember tangent lines from your geometry class? What was the tangent line? See how geometry comes to play a role? What was the tangent line in geometry?
Isn't it the line that touches the circle like only at one point?
Exactly. Very good, Amaya. There's your tangent line. So, if you want to know what the velocity is, remember we talked about instantaneous velocity as opposed to average velocity? If you want the velocity right here, draw a tangent line. If you want the velocity right here, draw a tangent line. If you want the velocity right here, draw a tangent line. Well, what's that last tangent line? What's the slope of it? 0, isn't it? So what happens at this location? What's the velocity? 0. Because again, it's moving away, and then suddenly the position is pretty steady right here. There's no change in position there. The x value hasn't changed right there for a little while. So at the peak, it's steady for a little while. Then again, it moves away from the detector until at the end, it moves back toward the motion detector at a steady rate with a negative velocity. Again, moves back toward the motion detector with a negative velocity at a steady rate. Okay, so my synopsis of that graph is a great interpretation or a great example of what you could expect to see as far as questions are concerned about the caliber and type of questions you would answer with the information I just gave you. Yeah.
So for that middle point right there, to find the slope, could you go
This one here?
No, the next one. Yeah. So to find that one, just go all the way down to the origin.
Make a triangle right here.
So you just do it
Anywhere. Rise, over, run.
But
No buts. Doesn't matter. The slope doesn't matter. You're incorporating the y-intercept. You don't need it. Why should I? You're going to say, extend this all the way and stuff. You don't need to. You don't need to use another point. You use the line you drew and just make a right triangle. Your rise is vertical. Your run is horizontal. Remember I told you, forget memorizing change in y over change in x. The length of this line, whatever it is, say this length is 3 meters and say this time period is 8 seconds. There you go. Your rise is up 3 meters. Over in 8 seconds, your velocity is 3 meters per 8 second, or 0.375 meters per second. So just take the rise over the run. Okay? It's a good question. It's a really good question. I had to ask it. It's a very good question. You should understand the concept of relative slopes on a graph. So if I give you a graph like this, and said which of the three graphs has the highest velocity? Velocity. Actually, let me make it tougher. Which of the four graphs has the highest velocity? That makes it tougher. Throw in that last line in there. Which has the highest velocity? What is velocity again?
Steepness of the slope.
The slope of the line, the steepness. Which is the steepest? The yellow dashed or yellow solid, or which one?
The
Yellow solid. How many people agree that yellow solid is the greatest velocity? You're the only one that's right. It is the greatest velocity. This one would be the common mistake because they think this is very steep right here. Again, this is steeper than this one is. This is steeper but in the negative direction. So this would have the highest what?
Negative.
Highest negative velocity, but you would also use the word what? Speed. Remember, speed is the absolute value of velocity if it's consistent. So the speed of this line here, so the velocity might be a slope of -7, whereas this slope might be only +5. So this has the highest velocity. Remember, velocity, the higher the velocity, the more positive it is. The higher the speed, it can be positive or negative. So this velocity is 5. This is 4. Let's say this is -3. And let's say this is -7. So the highest velocity is 5 meters per second. The higher the velocity, the more positive. Direction matters. But if I ask you which is the highest speed is 7 meters per second. Speed does not take into account the direction of motion. So the 7 being negative, I don't care about the negative. Just look at them now. Now which is the biggest? That's how you compare speed. Cover up the negative signs on the velocities, and that's how you compare the four speeds. So highest speed is 7, highest velocity is 5. What's the lowest velocity? Lowest velocity. Present. Which of these is the lowest velocity? Not the white solid. Not the white solid. Give me the number. Pick the number. I don't know. -7. Be careful there. So Will, the positives are not the only velocities. These are positive also. So if I ask for the lowest velocity, it means the most negative actually. Remember, velocity is a number line, speed is not. The lowest on a number line really means the most negative. Lowest velocity, lowest on the number line. Highest velocity, the highest on the number line. So highest velocity 5, lowest -7, highest speed +7. Okay? Because again, speed is absolute value if you only have the dimension. What else? What else? We have a few minutes still. What else? Yeah.
What's the formula instantaneous velocity?
So there isn't really instantaneous velocity. All you would do if you were given a graph, you'd have to use the slope of the line at that instant. Remember how Matei asked, how'd you find the slope of that line? I said draw a right triangle.
Like how
Yeah,
high it is. Like
because remember, instantaneous velocity is at that instant in time, isn't it?
Yeah.
And if you think about the formula for velocity, we've been looking at average velocity the whole time. Why isn't this working? We've been looking at average velocity the whole time. So that's a time period elapsed. The instantaneous velocity, how much time elapses? No time. That's the whole idea of instantaneous. The idea in calculus you learn is the time gap gets smaller and smaller. So let's say you found the average velocity between 1 and 5, and then 1 and 4, and then 1 and 3, then 1 and 2, until you find the time gap between 1 and like 1.001, and you find the slope right there. That's the instantaneous. But in this case, what I want you to be able to do is interpret it from a graph. Okay? From a graph. This is the average velocity. Yeah.
One of the questions kind of away from all this is the one about the metric prefixes. Sometimes I get confused about the whole centi, and just because it's 0.0.
Yeah, so the easy way to remember centi is just to go home and study a meter stick, or honestly, look at a meter stick today. There are 100 centimeters in a meter on a meter stick. because centi means hundredth. That's where the .01 comes from. Hundredth is .01 because there's 100 centimeters in a meter. Millimeters, there's 1,000 of them. So a milli is thousandth because 1,000 millimeters. So when I do conversions, I don't use the decimals ever. I happen to remember that there's 100 centimeters in a meter. So when I'm actually putting meter over centimeter, I just put 100 next to centimeter. There's 100 centimeters in 1 meter. If you wanted to, though, memorize that centi means hundredth, then you would put .001 for meter. So you'd have to do that one. If I were you, I would study your prefixes, but I'll give you guys a hint. You should know these ones for this test. Kilo, centi, and milli. I won't ask you giga or tera, or mega. Mega, giga, tera, I won't ask you any of those for this test. Because usually they're not given in those, okay? So those are the ones you should be familiar with. So you're practicing conversions, practice with those. That'll be my hint. Other questions? Let's see if there's anything else I want to point out. Amaya, you're coming later to the other class. Is it the first period you come to or the second? I forget. It's the first one. And you can't come to the second because you have another class during the second? Okay. All right. I'll make it work for you today again. I got to figure this out because it's tough because I wanted to do it the other way around, but it's fine. I can make it work.
Are there any problems where you find like standard?
Average speed?
So like SRP.
Sure. Absolutely. But you need to calculate the distance throughout the problem. So it might be like several paths along the way. You sum those together and just divide by time. Hey, the graph that we drew earlier, we haven't talked about this or we haven't used these words yet. But let's say I have any graph that does this. That goes from a positive slope to a negative slope. Maybe it does that, maybe it does that, maybe it goes up, pauses, comes back. For this to happen, are we recognizing physically what's happening? The person has to do what? In the middle. They're walking and then what do they have to do? Stop and do what? You all see that? Visually? The peaks are where they turn around. I mean, in this first case, they turn around right here, I guess. They go there, they stop, they wait, turn around and go. Or here, they're walking. This is like military. Ever see military do the about face? That's like they're turning quick and going back on this one. Here, they're actually going, they're slowing down, turning around, coming back. There's like a temporary little pause right there, you know, at the top. Okay, whereas here, it's like an about face real quick. I'm just trying to pick out things that I want to make sure are clear. Your math packet from the summer, if you want to highlight certain areas, let me give you a little hint. The area from problems, I think it was like 7 to 11, where you have to solve a formula for another variable. You'll have one of those for sure, it'll come up, for sure. So from like 7 to 11, one of those kinds of problems. You'll definitely have a problem with substitution method. That'll be in the math part. So that should be an easy problem for you guys. Remember substitution method, that was on the next page of the summer packet. Substitution method, it's solving for x and y simultaneous. That'll be in the math section. And then you can definitely expect problems that look like the graph. And those last problems with the rates, those rate problems are good to practice also. They're a little bit easier than what we've done with these, but those are good problems to look at still. It's all fair game. Yeah, dimensional, I told you already, there is, yep. Conversions. That's the same thing as conversions. About what? Look at your summer math package. Number 7 to 11, those problems that you solve a formula for another variable. You have to isolate a variable in the formula. One of those are after. Again, I have all problem sets that are hard copies. All electronics should have been submitted or else they're already late. So I hope they were submitted at the start of the period. Yep.
how do you put that instead of?
Yeah, so that's a good question. Scientific notation on the calculator, some have asked about. You're not the first person. So if I have a problem that says this, it says 5 times 10 to the third, I know how to type it in the calculator. I press 5, and then on the calculator there's a button that has 2 capital E's. To get that button, you press second, and then the button above the number 7. Press on the calculator. You have to have a calculator to know what I'm talking about right now. You press this button second, and then you press the button above the number 7.
Oh, it was above the comma.
So it's the comma, but I'm saying above the number 7. I was going to say comma, but some people it's an apostrophe, comma. I don't know which one it is. So second, and then press the comma. Okay, that'll give you a capital letter E like this on your calculator, and then it'll have the number 3. Type the number 3 afterward, and hit enter. Okay? That's what scientific notation looks like on your calculator. I've gotten this from like 3 or 4 people. That's why I'm just saying it now. That's what it looks like on the calculator. So to get that letter E, to put that letter E in, press second and then hit the comma. And that means times 10 to the. You don't have to do all the work for that. Those are equivalent things right there.
What is it, second?
The comma. It's above the number 7. There's a comma. And you should see capital EE. All right, so that's the keystroke for that. Yeah, you had the next question.
Can you just go back to the other side?
Sure.